Patterning is the way that we frame our design, and design is a subject of permaculture. If we look at the events like the growth of a tree will always start from a tiny seed on the ground. And the same pattern of the tree above ground is mirrored below in the roots. The movement of fluids in the tree actually go from the right side of the roots here, and when it reaches the point of germination, so in this case here, wherever the seed was in the ground, it actually switches over to the other side of the tree. So if the fluid was coming from the right side of the roots, at the point of germination, it will cross over to the left side to go up to the rest of the tree. And as we saw with the orders and sizes and scale of everything, right at this point of germination is where the tree is the largest, and that's where the movement of the fluids is the slowest. So at the tips of the branches and the tips of the roots, this is where the movement tends to be the quickest for all of the fluid that's happening. And this in itself, when this fluid is circulating through and crossing over, it makes a bit of a torus pattern. Which we saw with the tessellations. And this is a very, very common pattern, and all living systems actually follow this type of pattern. This moves us into edge and what kind of effects edge has on our system. The edge defines an area. The area still exists even if it doesn't have an edge, but it's hard to identify or visualize. So for example, even on this whiteboard, we have an area in the middle of this board that's maybe 20 centimeters by 20 centimeters. And if we remove that edge, the area still exists. It's just not very defined, and it's hard to actually see. If we take the profile of a human face and we take its mirror image, we can see that there's two faces looking at each other. But when we define an area, when we just put in two more lines, suddenly we get a candlestick. We get a totally different feel for what it is that we're looking at. So the edge is what defines the area here in this case. And this way of thinking about things is governed by using both the left and right sides of our brains when they're working together. So our artistic side and our logical mathematical brains both need to be working together to fully understand pattern and design. So again, when we have the area defined, it's a candlestick. And all that defines it is those two edges, and now it's two faces. So it's really quite simplistic when we're starting to see how things are coming together here. And actually, I'll leave that here for a second. And when we are young children and we're first learning how to color, we see a shape and we see an area that needs to be colored. And we start filling it in as fast as we can, and we go outside the lines, and it's kind of messy, and it's difficult to really fill in that area in a clear, concise way. So when we are taught to color, we're taught that if you start at the edge and shade in the edge first, then it's much easier to color in the area. So the edges in our designs as well are what's interesting. It's at the edges that we're able to accumulate surplus material. It's not in the broad area that we tend to accumulate a lot of this. We tend to dwell on the edges in our area as well. All the life around the edges is more diverse. There's a greater number of species near the edges. And so this is how we more or less think of our design as well, as the same as coloring, is we look at the edges first, and if we define those edges really clearly, then we can start to color in the area in between and start to fill that in. When we're looking at this in terms of a landscape, if we had a forest and then we had a field, our forest doesn't just end and our field just begin. Nature tends to fill in this area in between with smaller trees and smaller bushes so that there's a little bit of a transition between these two areas. So they don't just change from tall trees to grass. There's an edge system that occurs right here, and this band right in here is called an ecotone. So this is the most productive and diverse region in all of our designs. And if you look at something simple like just birds in a certain region, you might have 5 birds that dwell mostly in the field. And you might have 5 birds that dwell mostly in the forest. Sorry, species of birds, not 5 birds altogether, but 5 species of birds in each of these areas. And then you might have 5 species that dwell in the ecotone area as well. But what happens is all birds are going to visit this area. So these 5 birds from the field are going to overlap and visit this area. And these 5 species of birds are going to overlap and visit this area. So at any given time, then what you end up with is that you end up with 15 species of birds in this ecotone at any given time. And they all are going to drop manure, they're going to fertilize it, they're going to drop seeds in there, and they're going to make this area more diverse and more fertile than anywhere else. So only at these edges, so the edge between the forest and the field, otherwise known as the ecotone, only at these edges do you end up having a surplus. You'll have enough here and enough there, but you'll end up with extra here that will really help boost up the diversity. So other areas where this happens would be inside the bends of rivers. You'll tend to get quite an accumulation of material and fertility in those areas. The edge of the ocean where the land meets the sea, you'll also get a lot more productivity there as well. Where salt water meets fresh water, so in the estuaries, that's where we get the richest ecosystems on Earth, in the mangroves. The borders between land and water, there's lots of different scenarios as to where this edge effect starts to come in. So at the edges, we can get a surplus, but the edge can be changed, and it's not something that's set in stone, so it's something that we can factor into our designs. We can make less or we can make more edge to our advantage. And we also want to look at what kind of edge works best. So there's a reason why in agricultural testing, if you're near an area where they're doing a lot of tests with certain seed varieties or certain chemicals being sprayed or anything like that, you'll notice that there'll be a really large open field area, and they will never ever do the testing right on the border of this field and this field, because there's way too many variables that can occur right there because of this same edge effect. Nutrients will accumulate, things will drift in, you'll get cross-contamination, things will happen. So they purposely do their testing in the center of a field far away from all of the edges. So this is pretty much the opposite to what we're trying to accomplish, but it helps us to frame this idea in our mind that the most stable, boring, controlled area possible is the area furthest away from the edges. So this is not what we're aiming for whatsoever. The way that this edge effect was used in traditional cultures, so a lot of traditional people worldwide all understood the importance of this edge effect for enhancing the fertility of their crops. And it didn't matter where you were in the world. If you looked at tropical forest systems and settlements, they all followed a very similar pattern. So typically in a lot of these systems, there would be a village in the center, and this would be surrounded by kind of kitchen gardens. And so they would move this kitchen garden year after year all the way around the village. So 1 year here, 1 year here, 1 year here, to rotate the crop to make sure that they would have adequate fertility. And then for main crops, it was almost like spokes of a wheel. So they would very often, and keep in mind that this is all surrounded by rainforest, really dense forest. So what they would do is they would clear a section of land to produce their main crops. And they would usually farm it for a couple of years, like 2 or 3 years, and then they would move on to the next section, and they would clear the forest there, and they would plant a crop there. And this would give the land a chance to recover. They would often lie fallow for about 10 to 15 years as they worked around the circle. It would be about 10 to 15 years before they would move back to the same plot of land. And that gave it enough time to really build up the fertility in that area. And then they would either, when they got back around, they would either burn or cut down the forest and replant there. And there was very little effort once you cleared the vegetation because the soil was so fertile that you didn't have to do a lot. So you could keep on going continuously over time in this manner. But the area is what's interesting when we look at the edge effect, is that the area in all of these systems, whether you were in Asia or Central America or Africa, all of these civilizations realized that the perfect ratio of edge to area was a 2-acre plot of land in this forest. And this is, of course, before the time of the internet. And so how did these people know that this was the right size of land to clear? It's because they realized that if they made this area smaller, then it would be too shady. There would be way too many trees right next to it, and there wouldn't be enough sunlight to actually grow a productive crop. But they also realized that if they made it any bigger than 2 acres, then what would happen is the diversity and replenishing capabilities of this forest that surrounded that area wouldn't be able to heal it quick enough. And then, so they would go all the way around the circle, but this area wasn't quite brought back into fertility yet because the edge was too far away And so what they had to do was then they had to branch out and make even more of these. And they ended up having to clear way too much bush. Because if you look at the fact that most of these trees were probably cut with stone axes at one point in time, and I can't even imagine how long that would take to cut down trees with a stone axe, probably all day with several people working away at it. You wanted to make sure that you were always clearing the same areas so that the trees that you were clearing weren't really, really, really difficult to cut down time and time again. When you have a bulldozer, like we do nowadays, this isn't so important, but the problem is that we can clear land way too quickly, so we don't take into account a lot of these really intelligent systems and intelligent ways of bringing that fertility back in a natural way and cycling through, because we just go to another patch of forest and shove all the trees out of the way and start planting there without having any of this succession in mind. And that's really not sustainable. It ends up creating a lot more transport back to the villages and towns and cities than we really need. And so this is basically just a really simplistic idea of how trial and error worked, where traditional cultures realized that a certain amount of edge was beneficial for a certain amount of area.